going to discuss something about the Java modifiers. So here we are going to see what the different modifiers are, and we will see how and where we can apply these modifiers in our programs. Okay, so there's this table right in front of me which actually lists out all the different modifiers we have in Java, and it also shows at what level we can apply these modifiers, and it also shows us which modifiers can be applied at which level, right? Because not all modifiers can be applied at all levels. Okay, so let's first discuss what a modifier is. Actually, definition of modifier, as the name suggests, a modifier is nothing but it actually modifies the behavior of a particular item. Okay, so when you apply any of these modifiers to at any of these levels, it actually changes the behavior of that particular item after application of these modifiers. Okay, so basically you can categorize these modifiers into two categories. So you can say one is the access modifiers, which is all highlighted in red here. Okay, and the other category is the non-access modifiers, which is in black right here. Okay, so what are access modifiers and what are non-access modifiers? Basically, access modifiers speaks about the visibility of the item, or say for example the accessibility of that item to the outside. When I talk about outside world here, I mean other classes which are outside this class and outside this package as well. Okay, so when I say public access modifier, that means everyone outside this class can access this particular item. So when I apply it at the class level, everyone can see this class from outside this package or class, right? So we'll be discussing in detail about all these modifiers. So right now I just wanted to let you know that about the two levels we have, the two categories we have. One is the access modifier category and the other is the non-access modifier category. Okay, all right, so this is the list of modifiers which can be applied to a class. Okay, so we've got two access modifiers out here, public and default, and we've got three non-access modifiers, final, abstract, and strictly. Okay, actually you can also apply static modifier to a class, but that is when you apply it to an inner class. So we've got this other concept called inner classes. So but right now we are not really concerned about inner classes. The only thing we are talking about are normal classes, the outer classes, right? So static modifier cannot be applied to an outer class, so I won't be adding that at this point in time. Okay, so let's discuss how the application of each of these modifiers will affect the class on whole. Right, the first thing is the public modifier. So when you apply a public modifier to a class, it means, it says, as we've already discussed this one example, that anyone from outside the world can access my class, right, and can see my class. When you say default, it means that any class which is outside my class but within the same package can access this class. So if there is any other class within the same package, say for example my class is in the package called com.Sharad-Ballepu. So if any other class in the package com.Sharad-Ballepu, it can access my class, but any other class which is outside this package cannot access my class. So one thing here is default is not really a keyword, so you don't really say default class name. So when you actually want to specify a public class, how do you do that? You say public class name. But when you want a default class, you don't really say default class name. You simply say class name. So that means if you don't put any modifier there, any access modifier, it by default takes the default access modifier. And the only reason we've mentioned default is because we want to show what's the accessibility level, right, when there is no modifier, access modifier specified. Okay, and the other non-access modifiers are final, abstract, and strict FP. So when you say a class is final, you mean that the class cannot be subclass. That means if a class A is final, so you say a final class A. You say final class A, you cannot actually create a class B which extends class A. You cannot say class B extends A, because that will not be allowed if class A is final. Right? We will actually be discussing about subclassing and all those inheritance and all those things in the later parts of the session, right, when we discuss about roots concepts. Next, abstract. When you say abstract, it means that the class cannot be instantiated. So that means you need to subclass from your class, right? So how do you define it? You say abstract class name, right? So one thing here, I just wanted to make a note is you can only use one access class. I'm sorry, one access modifier for any of the item at the class level or any level basically. But you can use a combination of non-access modifiers for the same declaration, right? But there are some rules to that as well. So one example is you cannot use final and abstract together because the two are kind of contradicting each other. Final says you cannot subclass and abstract says you should subclass. So if you put both these together for a class declaration, it makes no sense at all, right? The next thing is strict FP. So when you apply this modifier to a class, it actually says that all the methods in your class conform to the IP standards for floating points. Okay. So these are the only modifiers which can be applied to class. Now let's talk about class attributes or instance attributes. So we've got all four access modifiers here. We can apply any one of these four access modifiers to a class attribute and some non-access modifiers as well, right? So we've already seen what private is. What public is. Anyone can access my instance variable, right? When I say public, say for example, public int I is equal to 10. So anyone can access the value of I from outside my class or outside my package. Next, private. Private means I can only access this particular instance variable from within my class. So no class outside my class, outside this particular class, can access the value of this instance variable, which is declared as private. Protected, it's got a special meaning. So protected actually means all the classes within the same package can access my class, which is same as default, but there is one more extra addition to this. So that is all the subclasses as well can access my attributes. So the subclasses need not necessarily be in the same package. It can be in some other package as well, but still it can access my attributes, right? So that is what protected all about. And default we've already discussed before, right? Now coming to attributes, when I apply this final modifier to an attribute, it actually means that I cannot change the value of the variable, of the instance variable, right? So I can assign the value only once and I can't again change it. So if I say int I is equal to 10, in some later part of the program I cannot actually reassign the value of I to 20 or something else, because that is not allowed when I apply the final modifier to the class attribute. Next, transient. What is transient? The attribute value cannot be serialized. So the first question is, what is serialization? So basically, when you want to save the state of an object for retrieving it sometime at a later point of time, you serialize it. So what do I mean by saving the state of an object? Now, say for example, I've got an employee class which has got an employee name, a department, and a salary. Just let's say these three instance attributes for now. Okay, the employee class has got employee name, department, and salary attributes, instance variables. Okay, and I assign some value to these instance variables. I'll say the employee name is X, the employee salary is Y, and the employee department is Z. Okay, so when I say I'm going to serialize this object, I will actually save the values of these variable, employee name, department, and salary, and then I'll be able to retrieve it back at a later point of time. So when I later deserialize it, I'll deserialize this object, I'll get the values as employee name X, employee salary Y, and department as Z, right? But if I apply a transient modifier to any of the class attributes, so say for example I've applied transient to the employee name attribute, so even though I serialize, on deserialization I'll get the value of employee name as null and I won't get it as X. But at the same time, I'll be able to get the value of the salary and department as Y and Z because we have not applied the transient modifier to those attributes, right? So a transient attribute, you cannot, attribute value will not be serialized when you apply the transient modifier. Next thing, volatile. Volatile, so when you are working on a multi-threading environment, so threads basically keep a private copy of all the shared variables, okay, and they do not, and they keep reconciling their private copy with the master copy of that variable at some not all the time, right? So when you actually apply this volatile modifier to a class attribute, it would always reconcile its copy. So this only with, usually use this only with the threads, right? When you have threads. Next, static. What does static mean? Only one value of an attribute per class. Now, so let's take an example. I've got the same employee class and I try to create two employees, employee 1 and employee 2, alright? And EMP1 and EMP2 are the instances, references for those two employee objects. And I assign the value ABC to employee 1's employee name, salary and department, and XYZ to employee 2, right? Now, if one of the, and upon retrieving, if I retrieve employee 1's values, I'll still get ABC, and if I retrieve employee 2's values, I'll still get XYZ, right? But if I have one class attributes as static, so say for example, I've got only one department in the whole organization, and I apply a static modifier to the attribute, department class attribute. So if I assign a value for this department attribute to some, say for example, K, right? So even though it from employee 1 attribute, employee 1 instance or employee 2 instance, now I still get the value as K. I won't get it as B and Y, right? So that means there is only one value of the attribute for the whole class. So no matter how many objects you create, there is only one value for this particular attribute which you define as static. And one more thing is, when you define a static attribute, you don't really have to create an instance of the class static attribute. You can directly access it using the class name. So you just say employee dot department. You don't have to create an instance and access it. So this is about the class attribute modifiers. Next, methods. So basically there are a lot of modifiers which you can apply to a method. So you have all the 4 access modifiers which we've already discussed, and we know what it is all about. So there's no need to discuss about these access modifiers. Coming to the non-access modifiers, when you say final, you mean that the method cannot be overridden. So basically, how do you override a method? You have class A, say for example, and you have a method called get salary in class A, and you have a class B which extends class A, okay, and you also write the same method get salary in class B. So that would mean you are overriding the method get salary, right, in class B. But when you define a method as final, you will not be able to override this method in your subclasses. Okay. Next, abstract. You only provide the method declaration and you don't provide any implementation. Okay, so usually when you write a method, you give some kind of implementation. So say for example, when you wrote this get salary method, you would have actually fetched the salary attribute value and returned it to the user, right? But when you have an abstract modifier specified for a method, you don't really have to give any implementation, okay? And so that would in turn mean you have to override your method. So again, if you see here, the final and abstract are two opposite things, okay? When you come to final, you cannot have to override your methods. So similarly, as you saw, strict FP with the class, the method conforms to all IEEE rules for 14 points. Okay. Synchronized is one important thing when you talk about threads. So only one thread can access the method at a time if you apply the synchronized modifier to that particular method. So basically when you multiple threads can access the same method at the same time. So say for example thread A is accessing get salary and thread B is accessing get salary, or it's not actually get salary, say set salary, and thread A is setting some value to the salary attribute and thread B at the same time is setting some value to the salary attribute. So at this point of time we are going to have some kind of inconsistencies because there are some shared variables which are being accessed both by thread A and thread B at the same time, and they are trying to modify those values of the shared variables. So there would probably be some inconsistency. So basically to eliminate such kind of inconsistencies when there are shared objects involved in the methods, you option, right? And when you have multiple threads, so when you apply the synchronized modifier to a method, only one thread can enter into that particular method at a time, so that you will not have any kind of inconsistencies. But it is not really a very good practice to apply the synchronized method for the whole method, because just for that little area part in your method where you are accessing the shared object, you are actually blocking your whole method from not having access to by the other threads. Uh, More smarter thing to do would be having synchronized blocks or synchronizing on the shared object itself. But synchronization is not the topic right now, so we'll just move ahead with that. Next thing, native. So basically if you have some kind of platform dependent language implementation, say for example you have got some C implementation to be done, then you can implement that in your you can use that C implementation, you can in the method when you apply the native modifier for your on your method. Right. And the next thing is static. So as we've already discussed about variables, the same thing applies to static methods as well. So you have you can directly access your static methods from using the class name. So you just say employee dot get salary, and you don't really have to create an instance of employee to get the salary of the employee. And one more thing is from within the static methods you can only access static members. If you have to access non-static members, you will have to create an instance of the class again to access non-static members of the same class. Okay, so if there is an employee class and the get salary is a static method, and say for example get employee name is non-static method, you can't really say get employee name in the get salary method. You'll have to actually create an instance of the employee class and then try to access the get employee name method out of it. Okay, so this is about the modifiers for methods. Okay, so how do you actually write give the declaration when you've got a combination of non-static methods and access modifiers and non-access modifiers for a particular item? So basically the access modifiers comes in first. So whatever, private, public, default, protected, any one of these, right? You can't have a combination of these now. Let's say for example the access modifier is public, and you give a you have non-access modifiers strict FP and strict FP and final. Okay, so you say for a class, so you say public strict FP final class name, right? So this is the thing. You give non-access modifiers first. I'm sorry, you give access of modifiers first, then the non-access modifiers. If there are many non-access modifiers, just one after another, the class declaration and the actual class name, right? Similarly for other items as well. Okay, and for local variables, the only modifier you can apply for a local variable is final. Okay. And by default the accessibility is private to the method or local to the method, right? So actually final is the only modifier which can be applied at all 4 levels, if you have observed that, right? So this is about the modifiers and